Alrighty. Welcome everybody. Good afternoon, good evening, good morning, good brunch to everybody. Welcome to our seminar, our webinar on effective strategies for digitizing hazardous zones with LoRaWAN. It's a joint webinar with Tektelic and Aircom and YZ Systems. And we are going to be presenting to you the full end-to-end solution for hazardous zones. So thank you for coming along today, and we're going to hopefully have some interesting things to share with you. Just wanted to go through who we have ready and waiting. My name is Corinne Newbury. I'm the Global Marketing Manager for YZ Systems. I'm based in the UK, so it's a bit later for me today. But I'm here to welcome you and to ensure the timings move smoothly, and also to facilitate the Q&A. So with that in mind, I just wanted to mention to you that there is a question button on your screen, or hopefully you'll see that. And if I can draw your attention to that, so that you can pop a question in at any point during any of the presentations, and we will have a decent bit of time at the end to handle any questions that you might have. If you wanted to direct it to a specific speaker, please do. Otherwise, one of whoever's best suited will be able to talk about that. And then we'll have Jack Stuart, Director of Business Development for Tektelic, Frank Rodriguez, Tektelic Director for Business Development and Sales North America, and Luke Bolton, Aircom Technical Sales Manager for North America. So thank you for joining us today. What we're going to be covering is an introduction to LoRaWAN technology. Jack will be sharing that with us. And then we'll move into the full end-to-end spectrum, from optimizing end nodes for hazardous environments that Luke will cover, moving into leveraging gateways for reliable data transmission, which will be done by Frank. And then into the network server, ensuring seamless connectivity, and Jack will handle that. And then enhancing data management with the application server, and Luke will cover that area. And then on to Q&A. So we really are covering everything, all the way from the end node all the way through to the network server. So it should be an application server. It should be really interesting, we hope. And on to Jack. Take it away, Jack.
All right, thank you very much, Corinne. Thank you for the introduction. And thank you to the teams at YZ Systems and Aircom for including Tektelic in this insightful webinar today. Just as a quick introduction, my name is Jack Stuart. I'm a Business Development Director at Tektelic, and we're based in Calgary, in Canada. As most of you know, Tektelic is a global provider of IoT infrastructure and solutions. We're very proud to be the leader when it comes to carrier-grade products designed for the highest performance, availability, and reliability for any deployment environment, including some very hazardous areas, which is, of course, the theme of this webinar today. And as we build our IoT portfolio, we do so with the primary goal of empowering our customers and our partners to achieve the lowest total cost of ownership when deploying and managing their networks. And we'll talk a lot about that today during the webinar. So now to kick things off, I'd like to provide just sort of a little bit of an overview of the IoT technology. The IoT technology that Tektelic and really the ecosystem has chosen as the leader when it comes to high-value LPWAN deployments is LoRaWAN. And today there are over 16 billion IoT devices deployed globally, and this number is actually projected to double in the next 5 years. And while many of these 16 billion devices are consumer-focused, BLE, Wi-Fi types of devices, the adoption and the deployment of low-power wide area network technologies, LPWAN technologies, is accelerating, and it's really transforming the way that enterprise and industrial IoT applications are operated. LoRaWAN, specifically, the LoRaWAN technology has really emerged as one of the most widely adopted and certainly the most successful LPWAN technologies, thanks to its long-range capabilities and ultra-low power consumption, which is made possible due to some, very efficient and very low data rates. Right in the name LORA, LoRa, it stands for long range. It's not uncommon for a LoRaWAN network to cover tens of kilometers in a rural setting or 2 to 3 kilometers in sort of dense urban areas, and also be able to support very deep indoor penetration for indoor use cases as well. This is comparable and sometimes even exceeds the coverage of a traditional cellular network. As I mentioned a minute ago, LoRaWAN is also designed to be extremely power efficient with a large ecosystem of battery operated wireless devices that can operate for 5 years, 10 years, even more, sometimes 15, 20 years in the case of some very low data devices, things like water meters that may not be transmitting quite as often. LoRaWAN is also a very cost-effective technology. So the long-range coverage capabilities and the power efficiency really paves the way for low-cost gateways and devices to be available in the market. But then when you also consider that LoRaWAN provides connectivity in the unlicensed or free spectrum, it guarantees LoRaWAN's success among the competing LPWAN technologies. And LoRaWAN networks are built to be very high capacity, meaning that a single LoRaWAN gateway can simultaneously send and receive data from thousands or even tens of thousands of devices, supporting millions of messages per day. And of course, LoRaWAN has been adopted as a global standard, which is backed by the LoRa Alliance, with deployments today in over 170 countries globally, and a growing ecosystem of hardware vendors, solution providers, integrators, and platform vendors like all of us who are on the call or on the webinar here today. Okay, so we can jump to the next slide, Kareem. So now I'd like to take just a quick look of the high-level architecture of a common LoRaWAN network. Today we'll spend a little bit of time during this webinar focusing on each of the components of a LoRaWAN network, but I'll just start with the quick high-level overview. So in any LoRaWAN network, you have your devices or your sensors, including, of course, the excellent products that are developed by Aircom, which Luke will introduce you to in a few minutes here. And those transmit data over LoRaWAN, potentially very, very long distances, as I had mentioned, to a LoRaWAN gateway. My colleague Frank will talk to you more in this presentation about the role of the gateway in the LoRaWAN network, but also the key differentiators and what you should sort of look out for when you're choosing a LoRaWAN gateway. The gateway itself simply just acts as a packet forwarder. It forwards the message onto a LoRaWAN network server. And most commonly, this is done through a cellular connection or an Ethernet connection. But we are starting to see more and more use cases in the ecosystem for satellite backhaul connections as well, which is very interesting. After the data leaves the gateway and is backhauled on, it hits the network server, which is really the brain of the LoRaWAN network, as it controls the network, and it also decides which packets are from a device in its network, and then makes the decision to accept or reject those packets, and then, of course, decrypt the packet if it's accepting that packet into the network. This is where all the security is housed for your network. This is also where you can make configurations for your devices and your gateways. So let's just say, for example, you had a device that was deployed and was transmitting data into the network every 15 minutes, but you wanted to change this reporting threshold to be, say, every 5 minutes, or even maybe based on some sort of event. These configurations can be managed within the network server. And then finally, of course, a network is really only valuable if you can visualize the data that's being collected and make decisions with it. And so that's where the application piece comes into play. Now today, Tektelic, we proudly provide end-to-end solutions. So we have our own very large portfolio of devices. We have the largest and most comprehensive portfolio of gateways in the LoRaWAN ecosystem. We have a network server. We have applications as well. But we also work very, very hard to ensure that this is an open architecture, an open ecosystem, meaning that each piece can be provided by a different partner and integrated to provide a very specific high value solution. So that's why we're so proud to collaborate with companies like Aircom to work together to provide practical, targeted solutions that solve real problems in the industry. All right, so we can jump to the next one. Now, before I pass it over to Luke to talk about the devices, I just want to reinforce that a lot of the key differentiators, or sort of the key kind of value of LoRaWAN that I just mentioned, really lend itself very well to being the ideal technology for IoT deployments in hazardous areas. The long-range capabilities allow users to deploy more devices and collect more data with less infrastructure required. It also supports, models where you have hazardous rated devices deployed on site, transmitting, potentially very long distances to gateways that are off-site, which is a very common architecture for hazardous locations. However, as you'll learn throughout this webinar, there are also more and more products available in the market that can be deployed directly on site in these hazardous areas, which is a great sort of evolution of the LoRaWAN ecosystem. The wireless battery-operated nature of LoRaWAN greatly simplifies deployment. And of course, the low power benefit lends itself greatly to reducing maintenance required to manage the network, because you don't have to worry about running power to all of your devices. You don't have to continuously visit sites to replace batteries or change out devices, anything like that. Going to a site to, replace a battery or to swap out a device can be very, very, very expensive. And that's especially the case when you're dealing with hazardous sites. So it's very important, and it's a very big benefit of LoRaWAN that you can, deploy devices and just let them sit there and do their thing. Not only that, LoRaWAN also allows for full remote management of your gateways and devices, which is a big reason why the LoRaWAN technology is ideal in helping users achieve the lowest total cost of ownership to manage their networks. And then finally, I've said it a few times, but the large and growing ecosystem of industrial LoRaWAN solutions is really outstanding, as it's becoming more and more, there are becoming more and more targeted solutions available to address the most common industrial challenges across many different verticals. So next, I'm going to hand things over to Luke. As I said, we're going to take you through the journey of the LoRaWAN architecture, and Luke is going to talk to you about optimizing the end nodes for hazardous environments.
Thanks, Jack, for that great introduction on LoRaWAN. So my name is Luke Bolton. I am the Aircom Technical Sales Manager. So I've been helping customers for the past 10 years to put together solutions surrounding control systems, instrumentation, and data handling. And for the past 2 years, I've been working with WiSY Systems to roll out the Aircom product line. So before we discuss Aircom, we'll just review a couple of the points that Jack touched on there for the typical end node in the LoRaWAN ecosystem. So these devices are battery powered. They are going to take a measurement and they are going to send that data, whatever it might be, temperature, humidity, tilt. There's a variety of data you can acquire through LoRaWAN end nodes, but that battery powered device is going to take that reading, it's going to send it to a LoRaWAN server. So in North America specifically, this utilizes the 902 to 928 megahertz license-free band, and it's going to transmit that data potentially miles away. You're going to have a gateway there listening, ready to receive transmissions. It's going to pick up that transmission and it's going to forward it to the server. So the majority of these LoRaWAN end nodes on the market are for safe area use, and they are not rated for hazardous areas. So that's where we come in. So if we go to the next slide, please, Kareem. So Aircom is actually an acronym, and it stands for Advanced Intrinsically Safe Radio Communications. So not only can we be placed into the hazardous environment, we are actually an intrinsically safe product. So what does that mean? So when paired with an intrinsically safe sensor, that sensor can take a certain amount of power safely to be powered, and our Aircom device limits the amount of power that it sends to that device, and it powers it safely, and it mitigates any risk of a spark in the hazardous area. So we can be placed into Class 1, Div 1 environments in North America, and we're rated for ATEX Zone 0. So the Aircom end node, it has 5 analog inputs. These can be used to power 4 to 20 milliamp active and passive devices. We can bring back 4 heart variables. We can read voltage, resistance. RTDs and thermocouples can be wired directly into the terminals, as well as a potentiometer. We can even change our setup and have our analog inputs change to be digital outputs. And that opens up the way for control applications. One of our biggest control applications is in the natural gas industry, where we control the gas pressure at regulator stations. We've got 4 digital inputs. These can be used as a volt-free and more, and we can even carry out high-speed pulse counting at our digital inputs. We can use them as a cry out. So let's say we're taking a pressure reading and we're sending it every 5 minutes, but let's say, we're monitoring a slam shut valve, the digital state. Let's say we send the transmission at 0 minutes and 5 minutes, but that valve closes at 2 minutes. Well, what the Aircom does, it will create a brand new LoRaWAN packet and send it immediately to get that data to the server, so we can see that change state for that valve straight away. So it doesn't need to wait until the next scheduled transmission. We have 2 RS485 channels, so we can actually use our end node to poll the data in another device's Modbus registers and take that data to the server. Some battery-powered devices for the hazardous area are only battery-powered, but we do have the ability on our device to supply power to the Aircom in auxiliary supply terminals. So this will need to go through an intrinsically safe barrier into the hazardous area, but this can be done with 12 volts DC. We can still leave a battery installed in the Aircom, and this can then be used as a fail-safe battery. But another really good feature of our end node is if you're just using the battery power of the end node in the hazardous area, let's say after 10 years the battery needs replacing, all you need to do is walk up to the end node, take the cover off, take the battery out, put a new one in, and it can be as simple as that when it comes time to change the battery. So, and the batteries can last a really long time, potentially up to 10 years. This just depends on the configuration and the application. And then if you've created your own network and perhaps you're bringing that data back over Ethernet around your site, it's going to cost you nothing to bring back this data, which is a real valuable feature of LoRaWAN in general. Okay, let's go to the next slide. So I just wanted to highlight a recent use case in North America. So this is a natural gas skid. So what's happening is there's a pipeline and there's a new factory that's being built. This factory is going to need a lot of gas. So what's happened is they've tapped into this pipeline. The gas is unodorized. So the gas comes onto this skid. It's odorized and it's metered before it makes its way into the facility. So the customer needed to monitor pressure, flow, and the data of the odorization. They wanted this to be a wireless device. They wanted it to be intrinsically safe. And the end user wanted to be able to view the data of this skid remotely on their laptop, tablet, and phone. So what you can see in the pictures here is it's a skid made by a company called Advanced Control Panels, and ISW manufactured the skid. And instrumentation by Vega and SICK and WiSY Systems is used on this skid. So at the top left, we can see a Vega diff that is being powered by the Aircom, and we're bringing back differential pressure. And then we've got 2 Vega bars supplying the inlet pressure and outlet pressure of the skid. And then we've got a FlowSig 500 that's giving us a corrected pulse for the flow of the gas coming through the skid. And then at the bottom right there, we can see the WiSY Systems NGEX odorizer that is precisely odorizing the gas. So if you just turn your attention to the bottom left of the slide there, you can see the I/O that's being utilized by just one Aircom. We've got 3 analog channels, 2 digital channels, and a serial channel. So we're utilizing 6 I/O channels with just one end node. If we go to the next slide here, Kareem. So let's just talk about the benefits of that. So typically, other end nodes in this sector, it may be a 1-to-1. You may have one end node, one pressure, or you may have perhaps 2. So at a minimum, you would need 3 of competitor end nodes to be able to bring back the data from all these devices. So let's just highlight the benefit that Aircom brings to the table here. So if you install one Aircom instead of 3 of our competitors, that's going to save you capital when you're deploying at scale. You're going to need less end nodes overall to bring back the same amount of data. And what that means is it's going to put less pressure on your gateways and your server when all this data is being sent. When it comes to the battery replacement for these devices, the some end nodes, you may need to take the instruments off, you may need to take them out of the hazardous area, and you may need to open them up and replace the battery. The beauty of the Aircom is all your maintenance technician needs to do is walk up to the device, take the cover off, take the battery out, put a new one in, and it's as simple as that. And if you've only got one to do instead of three, it's going to save time and money. You also have the ability to add in another sensor at a later date if a new data point needs to be recorded. It's as simple as wiring in another instrument, using the app that's free to download from the App Store and Google Play Store. You turn on the Bluetooth channel on the device, you connect to the device, you update the configuration, and there you go. You've got another instrument that you can use, and it's really simple and can be done in the hazardous area. So Aircom can save you time and money long-term on these applications. Next slide, please. So just one other further update on the Aircom end nodes. We do have a new product that's available starting next year in North America. So it's our Aircom Mini. It's the same features we've discussed, just a smaller footprint, less I/O, and a lower cost option for different applications. So that's our Aircom end nodes. So these devices will collect the data, they'll send the transmission, and that data will go then to the gateway. So to speak on the gateway, I'm going to pass it on to Frank Rodriguez.
Thank you, Luke, and thank you, Jack, earlier. So my name is Frank Rodriguez, and I'm the Director of Business Development and Sales for Tektelic in North America. A little bit of background on myself. I've only been with Tektelic for just less than a year, but in the industry, I've been around industrial IoT and IoT applications back 20 years with Verizon. So Verizon was my 20-year long career. I went to work for Sierra Wireless, which is now Semtech, which, as you know, manufactures a lot of LoRaWAN devices, and also worked for Cradlepoint, which is now Ericsson. So that's just kind of my background. What I'm going to talk about in the next few slides is why Tektelic is unique in the space, on the LoRaWAN gateway manufacturing space, more specifically. And I'm going to be highlighting features and functionality that really set us apart from the industry. If we can go to the next slide. So what are the key design principles that really sets Tektelic apart? I know Jack earlier spoke about some of these, but I just want to hammer down on a couple. Again, when you take in the first block, low deployment and operating costs, when you take a package that you're deploying in over 10 years, the cost of deploying a LoRaWAN gateway infrastructure with devices represents 5% of the overall cost, and that's over a 10-year period. The second design principle that is really stands out is we design all our gateways to be what we call a carrier grade. We want them to operate and to have the best performance. We want them to be reliable, and we want them to have a really long life. So again, as Luke spoke to earlier, Jack, those are kind of the real design principles that are different and unique in the space. The third block is portfolio diversity. If you look at our portfolio, and I'm going to show you a slide in a moment, we have a gateway that fits just about every unique case you may have that would match appropriately to whatever the case is in that scenario. And this is unique in this space. There's really no other competitors that have a unique and diverse portfolio like Tektelic has. And then finally, we all know proprietary platforms are probably everybody's steering away from. We're an open system. We will talk to any device in any LNS as well as having our own LNS to offer. But again, we're an open platform from a forward end and back end. And next slide. Okay, this is really a testament to our uniqueness. We have a lot of devices, gateways to offer customers. On the top left, the top row represents our IP67 or rugged devices. They come in Mega, the Mega EX, which is our hazardous certified Mega, which I'll highlight in a moment. The Macro, which is a middle of the road device. And I'm going to be talking a little while about the Kona Macro EX version, which is our new product. And then one other device that's gotten a lot of attention is our integrated solar panel cellular gateway, and that's the Kona Photon. The bottom row, bottom left, are two unique devices or custom. Again, we will work with customers who have a specific need and develop something around that. And so we're not afraid to walk away from some projects like that. Enterprise is a lower end version, and the bottom right two are our indoor versions. So if you have a solution that requires indoor, we have that as well. So again, when I say we have the most diverse portfolio, it's pretty evident. Okay, this slide just kind of talks about how we have devices that will, gateways that will work in any environment. We designed them to last forever. So in mountainous scenarios, you see there, one encased in ice and snow, whether it's along the coast, we have designed our gateways to be salt fog tolerant. Obviously, corrosion can really end the life of a gateway. We designed them to not be not able to survive, to be able to survive those environments. If you'll notice, all the glands, the connector glands, are on the bottom. That is one of the reasons why they're there, is we don't want any condensation, moisture residing on the top, causing premature failure of the gateway. As far as diverse density, cities are really dense environments, and we design features and functionality into our gateways to overcome some of that. And of course, extreme temperature swings in deserts. When you look at how we design our gateways, we want them to last 10 years in the field, but it's not unheard of we have a 15-year mean time before failure of gateways. We want you to be able to remote manage these devices with our platform, do software updates, upgrades. Those are all functionality that come with a Tektelic gateway. Next slide. Okay, I'm going to talk a little bit about our Kona Mega EX. This is our flagship gateway. This is a Class 2 division, Zone 2 rated. It's the first of the kind in its marketplace. You can see on the right, it's a all-in aluminum enclosure. It supports up to 64 channels of connectivity. And why that's important is it's able to connect to literally thousands of devices in that area. So it has a lot of capacity. It has a third bullet I want to really stress. It has a integrated active bandpass filter. And why this is important is we're able to block out all of the RF frequency that has nothing to do with LoRa. So we're able to have a clean signal delivered to your gateway and able to provide excellent communication in the field. It's IP67 rated, as I mentioned earlier. Built-in lightning protection. Now, this is something that most folks would have to add afterwards. We built that right into the case. And as far as a backhaul, Ethernet is an option, or if you want to do wireless 3G, 4G, we have a variant for that as well. And of course, I mentioned earlier, all of this can be upgraded remotely, software updates, operations, administration, all done with using our tools, and we offer that to our customers. Next slide. Now, this is the one I'm really excited about. This is a new product. It's the Kona Macro EX. So we have a macro, but this is the Hazardous certified one. I really want to say how this is very unique at this moment. This is a Zone 1, Division 1 ATEX certified device. Very unique. There's nothing in the marketplace like this. You can see it's built almost like a tank. It's bolts all the way around, aluminum case. It's built pretty substantially. As well as it comes with the cavity filter, so we're able to block out RF. It's not part of the design. But also the fourth bullet, I want to really highlight, this has a new radio technology embedded in it. The low noise figure and the low oscillating phase noise are functionality and features that allow it to get the cleanest signal, keeping the device tuned into the frequency. So it provides an optimum wireless scenario, especially when you're in a scenario where there's a lot of background RF, a lot of other signal that can interfere. This device can connect and stay stable. Again, same Ethernet, 3G, 4G backhaul, and of course, ability to manage this remotely is definitely a plus in this model. Again, this is new to us. Very excited about it. Again, I talked to you earlier about the use case. The portfolio. We have devices that fit every unique use case. Oil, gas, chemical is probably the predominant customers in this market. I live in Texas, so oil and gas, chemical processing, pretty standard. Mining, there's also needs for mining and pharmaceutical manufacturing. So whatever your particular use case, we have a gateway that will provide you that type of hazardous connectivity in those locations. Next slide, please. Okay, part of the difficulty, again, seen with putting wireless inside of a large metal facility like a chemical plant, is you have weak signal, no signal. All this metal ends up being an RF Faraday cage blocking signal when it's concrete, materials in the way that are kind of blocking that signal. We all know LoRaWAN was designed to reach a long distance, but again, having something located offsite or in this property, especially, can be very cumbersome. There are things like RF path loss, shadowing, and then there are customers that will take a gateway and encapsulate it in an enclosure, and that reduces the performance. This is something that Tektelic can solve for. Our portfolio of devices can eliminate a lot of these concerns, things that you'll experience in those environments. Next slide, please. Okay, again, Tektelic is the leader in this space. You can deploy your devices in those areas where you have signal loss. You don't have to locate that gateway far outside of that perimeter. With our new Kona Macro or the Mega EX, you're able to locate it in the location nearest to all your devices, eliminate the need for any type of additional equipment or to extend power. We can put it right near where the source, where the data is being captured. We offer a ton of diversity to improve that as well. And again, understanding the fact that we're the leader in the space and building in cavity filters to block out RF that has nothing to do with your operations is key, because you don't have to deploy as many gateways to cover that same geography as you would, say, if it were Wi-Fi or some other IoT wireless solution that doesn't have those advantages. And I want to thank you for allowing me to talk to you today. Welcome opportunities to meet with you individually as we move forward into this webinar. Thank you.
All right, thank you very much, Frank. That was great. So as we continue through the journey of the components of a LoRaWAN network, Luke talked about the devices. Frank just gave some great insight into the gateways, and now I'd like to spend just a couple of minutes focusing on the LoRaWAN network server. So we can jump to the next slide, Karine. First of all, so what is a LoRaWAN network server and why is it needed in your network? As I mentioned before, the network server is essentially the brains of your LoRaWAN network. It acts as the central management hub of the network as it coordinates the communication between the hardware, so the devices and the gateways, and your application. One of the primary roles of the network server is data filtering, processing, routing. So when devices are transmitting packets into the network server is responsible for processing these packets. Like I mentioned, the first thing it's going to do is it's going to evaluate whether or not the message that's being received is coming from an expected device in its network. And if so, it will process this packet into the network and eventually on to the application. And if not, it'll simply just throw it away. So all of the data being transmitted by any LoRaWAN device will first land in the network server for processing before carrying on to the application. The network server also plays a very key role in the security of the network. So this is where all of your authentication and encryption is managed. A LoRaWAN packet by default is encrypted, meaning that if you were ever to intercept a LoRaWAN packet prior to it reaching the network server, there's really nothing that you can do with it. And the network server actually holds all of the keys to the devices in the network, meaning that when a network server receives a packet from an expected device, it's going to evaluate its database to check to make sure that the message that was received is coming from one of its devices. If so, it will verify that it has the appropriate key to basically unlock or decrypt that packet, and only then will the message be accepted into the network and decrypted. The network server also plays a very key role in gateway and device management. I'll talk a lot more about gateway management in a moment, but from a device perspective, the device configurations are managed in the network server. So let's say, again, I gave an example earlier, but let's say you had a tank monitoring application and you had a tank monitoring sensor that was transmitting tank levels into the network every hour, but you wanted to receive this data more frequently, say every 15 minutes, you would manage this configuration in the network server, and then you would push that configuration down through the gateway to tell the device, okay, I want you to change your reporting threshold. This is where you can also set up things like threshold, like event-based thresholds and alarms to force a packet based on a certain event happening. So, for example, like a leak being detected for a leak detection use case, or when an asset starts moving, or maybe an employee is wearing a LoRaWAN connected safety device and that employee falls down and you want to trigger an uplink into the network based on those sorts of scenarios. All of that, again, can be managed in the network server. And then there's also a great deal of network monitoring capabilities managed by the network server as well. So the network server provides data about the performance of the network and the health of the entire network, including tracking key metrics such as like packet delivery rates, signal strength, signal quality, those sorts of things. So we can jump to the next slide. So Tektelic, as I mentioned earlier, we have a network server as part of our portfolio, which is called Kona Core. Kona Core is used by many of our enterprise customers who are deploying their own LoRaWAN networks and is designed for high performance, reliability, and to reduce the overall total cost of ownership of our network operator partners. It's built on a high availability platform that scales to tens of thousands of gateways and millions of sensors to meet the demands of the most challenging networks. So we can jump to the next slide. Tektelic really takes great pride in ensuring that all of the LoRaWAN network components that we offer, as I mentioned before, are completely interoperable with the LoRaWAN ecosystem. And this, of course, also extends to our Kona Core network server as well. So we have open support for any third-party LoRaWAN gateway, any LoRaWAN device, ensuring that we're never, ever locking in our customers and empowering them to grow and scale in the LoRaWAN ecosystem. Kona Core has an open API to integrate seamlessly with almost any IoT platform or application, just like the one that Luke will speak about here in a moment. And it's most commonly, the Kona Core is deployed in the cloud, but it can also be deployed physically on premise, on site, and a physical machine as well, for the use cases that require that sort of extra level of containment and security. And it's very, very, very reliable and highly available. Between all of our customers and partners using Kona Core today, there are tens of thousands of gateways, millions of devices connected, and we're achieving over 5 nines of availability, ensuring that our customer networks are always operating without interruption. Now, earlier, Frank walked you through the gateway story and Tektelic's portfolio specifically, and I'd like to just take a minute to talk about our Kona Element Operations, Administration, and Management Server. So I mentioned earlier on in the presentation that Tektelic's goal is to empower our customers to be able to deploy and manage LoRaWAN networks for the lowest total cost of ownership over the duration of the full deployment. So typically that's over 10 years. And there's really no better way to showcase this than with this tool, Kona Element. Kona Element is essentially a remote gateway management tool that allows you to remotely manage, configure, provision, and monitor your gateways from literally anywhere in the world. Kona Element even includes performance indicators like spectrum analysis, spectral scans for real-time visibility into the performance of your network. Now, all of these remote management capabilities are included in Tektelic's network server as well. But like I said, we want to ensure the success of all of our customers, no matter which piece of the LoRaWAN puzzle we are supporting them with. And for this reason, we make all of these features available to any customer who are using our gateways with any LoRaWAN network server via the Kona Element tool, which is a standalone solution that, like I said, can be used with any LoRaWAN network server. A single site visit to, repair a gateway or troubleshoot a gateway is going to cost way more than you ever paid for the gateway in the first place. So having the ability to monitor, manage your gateway completely remotely is absolutely essential to ensuring that you're operating a cost-effective LoRaWAN network. Tektelic, we've been in the LoRaWAN space for around 10 years, and we've been supporting LoRaWAN projects for this entire time. And we know that the actual cost of the gateway in a LoRaWAN network deployment is really only about 5% or less of the total cost to deploy, manage, and operate the network. So if we provide tools and solutions to our customers like this, which will help them reduce that other 95%, we believe that we're doing our part to promote the mass adoption and scaling of IoT and LoRaWAN. Okay. And then finally, I'd just like to give a little plug here to a very valuable tool that Tektelic has recently released called Kona Radiant. Kona Radiant is a very valuable RF coverage mapping tool that's offered by Tektelic, but it has been designed very specifically for LoRaWAN networks, which is a really sort of valuable thing. It greatly simplifies the process of network planning and deployment. And really all you need to do is deploy a gateway along with a handful of sensors, and you can assess RF performance in real time almost immediately. So this allows you to quickly identify the optimal location to deploy your gateways, your sensors for the best coverage and the best reliability and performance of your network. One of the best features of Kona Radiant is really how quickly it can be deployed. You can set up the kit in just a few minutes, making it incredibly simple to conduct coverage testing, which can sometimes be a complex or challenging task. Just to give a quick example, about 6 weeks ago, we hosted a customer event in Amsterdam at a hotel in central Amsterdam, and we did a live demo of this Kona Radiant tool while we were there. And literally, we plugged in the gateway in the room where we were hosting the event. Our president, Roman, actually had a little bag of about 10, 12 devices. He ran around the building, deploying them all through the hotel. And within minutes, we were able to showcase a real solution of, how each of those devices were performing, the connectivity, the packet success rate, the RSSI, most importantly, the signal quality being received by each of those devices, or being received by the gateway from each of those devices. So once you have Kona Radiant deployed, we have a very simple application that you can see kind of in the screenshot there that provides real-time monitoring, allowing you to see sort of the live data about those metrics I just mentioned, packet success rates, signal strength, signal quality from each of your devices. And it's delivered in a very sort of user-friendly interface, so that kind of a color-coded interface, so you can very quickly see which gateways are performing, or which devices are performing well, which devices may need to be optimized in terms of their placement, or if another gateway needs to be added, those sorts of things. So it's a very kind of valuable, simple to use tool that's going to help you be more effective in managing your deployment and your network. So I'm going to throw it back now to Luke, who will talk about the application piece of LoRaWAN, of the LoRaWAN puzzle, before we wrap things up.
Jack. So like Jack mentioned, the network server really is the brains. It handles the security and the important job of getting the data and putting it in place. If you go to the next slide, sorry, Karine. So what a typical application server will do is it'll take the data in, and it will use the payload decoders for the devices to decode the data, and it will make it available for visualization and trending, so that you can start interrogating that data and making use of it. So if you are using your application to control as well, then it can or just send new downlinks. It'll queue those downlinks up, encode them on the way out to be passed to the network server. So other typical application servers can host an MQTT server. So that will publish the data from the end nodes, which means perhaps third-party applications or dashboards can subscribe to that data and visualize it elsewhere also. And that's available securely utilizing MQTT over TLS. So let's go to the next page. So Aircom do offer an application server to visualize the data. So just some of the highlights on the next few slides is once you land on the page, you can see your devices there. You can quickly see the devices that are online. If there are any offline for any reason, you can see the latest measurements from and values from those end nodes. You can perhaps use a map of your site or facility, and you can zoom in onto the location you're after, click on it, and see the latest values, or go to the history. Let's go to the next page. Another cool feature is once you do select the end node that you want to take a look at, you can quickly see the data, and you can set the range that you want to see, whether it's something that's happened in the past hour or maybe a week ago. You can set the exact time period that you want to look at the data for, so you can trend that data. You can overlap different channels over one another, so you can compare it, and that really helps to give you an enhanced view of the data and evaluate that data. Next page. And then let's say you've got an application whereby you've got some end nodes monitoring pressure, and you want to make sure that the pressure doesn't exceed a certain amount. What you can do is use the application server to set alarms. So say it exceeds that pressure value, then you can make sure the operator gets an email sent to his account. Or let's say it's really a bit more critical, they could get an SMS sent to their phone, so they can be alerted when these certain scenarios arise straight away. Let's go to the next page. So the dashboards that can be built out to visualize this data really can be very custom. You can also integrate third-party dashboards that can subscribe to the MQTT broker's data. So the dashboard that we can see now is the dashboard that is being used for the skid that I showed originally with the Vega devices and the flow stick. So you can see there that they can visualize that data. An operator or a technician can take out his tablet in the field, take a look at the data that's been coming in and interrogate it, and it really helps them to get a better understanding of what's going on. So dashboarding can be created. You can have custom reports generated on the data. And if you want to take the data somewhere else, we could do a custom API, and that data can be pulled wherever you want it to go. So that's really the application server in a nutshell, visualizing your data. Just a couple of points for final consideration. So both the Aircom and Tektelic network and application servers, they can be based in the cloud, or they can be on-prem. So they can be on your private network if being on the cloud is not something your organization is interested in. If you've already got a LoRaWAN network server in place, and perhaps you're looking to upgrade your gateway hardware, or you've got another application that you're considering other end nodes for, and you perhaps just want the Aircom, then that's the beauty of an LP1. You can keep your existing servers in place and seamlessly just integrate a Tektelic gateway or an Aircom end node. And that's really the point that we'd like to drive home with this webinar. We are happy to discuss your current journey that you're on with LoRaWAN and just see which part you may need our help with. So with that, I'll turn it back to Kareem with the Q&A.
Fantastic. Thank you very much. Right, so we are on to our Q&A section. I remind everybody, if there are any questions that you have, please pop them into the question panel. And good news is that we have a couple coming through, and I'll read them out, and then we can have whoever's the right person to explain them. So we have a question here from Mohammed Emad. You said Kona Mega X has 64 channels, but you also mentioned that hundreds of devices can be connected to a gateway. Could you please clarify? Also, what would be the battery life if the end devices were to send data every 2 hours? Who would like to take that? Frank, you look like you're ready. Jack?
Yeah, I'll take a crack at that, and if Jack wants to add any other color, he can do so. So again, the Kona Mega EX, it has 64 channels, means it can manage signals on 64 separate paths. Each channel can handle transmission from multiple devices simultaneously. This design allows a gateway to support hundreds of devices at once. Again, these transmissions are spread across the channel, so I'm only speaking to the capacity of the Mega. It's pretty large. And as far as battery life, I think battery life is something that's configurable. It's something that can be observed through our platform to validate if, in fact, maybe the device needs to be configured differently to support a longer battery life. But every 2 hours is pretty, I would imagine, fair. Jack, do you have any color to add to that?
Yeah, one thing I'll maybe just mention with regards to the sort of device capacity of the gateways, and specifically Kona Mega EX. So Frank had mentioned about the 64 channels. We've done lots of calculations over the years, as has, many of the vendors, gateway vendors in the LoRaWAN ecosystem. And we always get asked, how many devices can you actually connect to a single gateway? And it's not really an answer that we can give in terms of number of devices, because you could have a device transmitting every 2 hours, like Mohammed mentioned, or you could have a device transmitting every 20 seconds, right? So the capacity is going to be very different. But for the Kona Mega, specifically, we've calculated out about 650 messages per second that can simultaneously be sent and received from the gateway, which translates to about 12 million messages per day. So it's a very, very, very high capacity. If you consider that most devices in LoRaWAN anyway are only transmitting every 5 minutes, every 15 minutes, every 30 minutes, you can very quickly see that the capacity of the number of devices that can talk to a single gateway is absolutely massive.
Excellent, thank you. Let's move on. We've got a question from Glenn Mitchell. Is the LoRaWAN network an IP-based network? Does the individual pieces have IP addresses? They ask. Who would like to?
I can take that one. So no, LoRaWAN devices are not IP-based. Instead, they have sort of unique identifiers. They call it, in LoRaWAN kind of terms, they call the device EUI or a dev EUI and an application EUI. So they're not traditional IP-based. It's not an IP-based communication protocol.
Excellent. Question here, possibly for Luke. What voltage can the Aircom output on its digital outputs?
Yeah, so it would more than likely be a 12-volt DC output that people would be looking to utilize, but the channel can output 10.5 to 16.4 volts DC.
Excellent, thank you. Another question here from Modar Spat. Is there any application related to wildfire alarm systems? That's an interesting one. Anyone heard anything about wildfire alarm systems?
I don't know if, do you guys do one of those at Tektelic for an end node? You don't, right?
We don't for an end node,
Yeah.
but we certainly have supported some wildfire detection projects in North America specifically. So we can follow up and share some of the details about that because it is definitely a use case in the LoRaWAN ecosystem that we've supported in the past with our gateways anyway.
Excellent. Question here from Joseph Renk. Can you talk about the Tektelic LoRaWAN GPS devices? Sounds good.
Sure. Frank, do you want to take that one or do you want me to take that one?
Yeah, if you don't mind, Jack. Again, we do have GPS in our gateways, but Jack could probably better answer that than myself.
Yeah. So Joseph, we have a very large and kind of growing portfolio of devices at Tektelic, including many that utilize GPS for outdoor positioning. So we have devices to track sort of large assets that utilize GPS for outdoor positioning, but then also have Bluetooth inside, or in some cases Wi-Fi inside as well. So if that asset is to move into an indoor environment, you can continue to track it. We have GPS connected devices for monitoring assets. We have GPS connected devices for monitoring people, including safety devices that incorporate GPS and Bluetooth. So we can definitely send you some more information on our full asset tracking portfolio after the webinar, but we've got a very, very comprehensive and growing GPS tracking and asset tracking portfolio.
Excellent, thank you. I think these might be follow-up questions from Luke's earlier question. We have one from Todd Simino. What current? I think you were saying DC, but Luke, I don't know if you wanted to touch on that. And then Jason Hannum, with the Aircom, if you're on 12-volt power, what is the max update rates for the analog inputs? Do you want to answer the current question first, Luke, perhaps?
Yeah, whatever's in the intrinsic safe certification. I'm not sure the max current that can be output, but it will be in line with that. And then update rates for the analog inputs. In North America, we can send the data as quickly as every minute. So that'll be transmissions to the network.
Fantastic, thank you. Right, a question from Larry Liang. What does the Radiant tool include? Gateway plus utility tool? Does it output a 3D RF model that can be ported into an application?
Yeah, I could take that one. So really what Kona Radiant contains is that you get a gateway and you get a kit of sensors. So let's just keep it simple, say 10 sensors, and then you get um, access to this application that we've developed. And when you open up this application, we will have already integrated all of those sensors into the application. So you'll see your devices. And as soon as you activate those devices, get them online, pull the battery tabs, you'll start to see I'll call it real time, but you'll start to see information from those devices as they start to uplink into the network. So they'll be configured to uplink, say, every minute, and you'll get from each of those devices, you'll get an RSSI value, you'll get a calculation of packet success, so how many packets are being received into the network. And I think most importantly, you'll also get a calculation of signal quality. So we're not just evaluating RSSI, our gateways that we have are designed to really sort of, bring down the power, reduce the noise that's, happening in the network so that we can also evaluate very confidently signal quality. So you'll see that in a list. You'll see your list of devices and you'll see those metrics. It doesn't produce like an actual map, but it just provides those metrics, and then it has some color-coded guidance based on the metrics that are being received. So Larry, we can definitely walk you through a demo of Kona Radiant at any time. That's no problem.
And Jack, while you're on the Kona Radiant question, we have one here. For Kona Radiant, can you please explain how that works? Can this tool produce heat maps? Can we run it in a real time? Is it a feature already available for customers at no additional cost?
Yeah, so I think I just explained kind of at a very high level how it works. It's available. Yeah, it's available today. We released it maybe about 2 months ago or so. There is a cost associated with the hardware. So I mentioned it includes a kit with gateways and devices. So there's a cost, of course, associated with the hardware. And then depending on kind of your maintenance support relationship with Tektelic depends on if there's sort of an incremental cost for the access to the tool or not, but it's very, very minimal. The biggest cost, the main cost associated with it would simply just be for the hardware.
Excellent, thank you. Here we have a question about free trial. Is there a free trial for Kona Core and also for Aircom?
So for Kona Core, we do have POC, a POC account. So we, for customers who are using Kona Core for the first time, we do have a trial period available. I'll let Luke answer about Aircom.
Yeah, I'd say get in touch and let's have a conversation and understand the remit of it.
Excellent. Right, last few questions here before we finish off. We've got one here from Emmanuel Pontes. You explain RX linearity and RX NF. I feel like I'm reading something like some kind of interesting code.
I'm not sure I'm the best one to take that one, so I don't know.
I don't think I'm the best one either.
I don't think there'd be time left in the webinar to get into the depth of it, to be honest.
Alrighty, I think Emmanuel, that one might be a little bit too tricky to handle just in a brief Q&A, but we will be sending out details following this webinar and with links on who you can get in touch with. And just the last few questions here. Does Tektelic have an online store to purchase devices that have been tested to work on the platform? That's a great question.
So we don't have a web shop specifically, but we have our products are available through many different online marketplaces. So I see Larry Lang's on the call, so Embedded Works is a good one. If you check Embedded Works, you'll find a lot of Tektelic products on there. And we have some other online distributors as well. If you get in contact with us directly, we can put you in touch with the best place to get you a hold of the products.
Fantastic. And last two questions just before we finish. Gerardo Flores Para asks, how can we implement your platform for our customers' use and what is the cost of it?
Yeah, I'd say it
Not sure.
depends. So just to get in touch and take it from there, understand the application.
Quite application specific, yeah. And the last question from Jason George, regarding Tektelic Radiant, I assume we're paying for the GW and sensors. What type of sensors are included in the kit? Can we pick what type since we could then use them for a useful use case?
Yeah, so by default, we include our comfort sensor, which is just sort of a multi-purpose indoor environment monitoring device. But we can definitely have a conversation because there's nothing stopping us from utilizing any of our devices with the tool. So yeah, just have a conversation with your sales rep at Tektelic and let them know which devices you're interested in, and we can make that work. That's no problem.
Excellent. Well, thank you to everybody for your questions. That was quite a good session. Anything else, please do get in touch. We will be sending through some information following the webinar with links as well for you to rewatch in case you wanted to catch anything that you might have missed. Thank you to Luke Bolton, Jack Stuart, and Frank Rodriguez for your excellent input and great visuals and explanations. And we look forward to welcoming you another time for another webinar, hopefully. Have a wonderful day. Bye.